All right, sixth graders, this is exciting. We're going to learn about solving equations today. And this is something you're going to be doing from here all the way through 7th grade and 8th grade math, is solving equations just like these. So we're going to look at some really basic equations with simple numbers, and we're going to talk about the process of proving the answer. When you're solving an equation, you're going through a process of proving what the answer is. Okay? So, this is what equations look like. One side has a variable on it, and in this case, the other side just has a number. What does this equal sign tell you? That both sides are what? They're equal. They're perfectly balanced. They're equal. The value of the left side is equal to the value of the right side. Okay? So that means that n is a number. N is a one number that makes this side equal to the other side. Okay?
Then it would be 3 and 5, right? And
That n is 3, right? We know n is 3 because 3 plus 2 is 5. Right? Is n the number that we're writing n for? Remember when we wrote that a number plus 2?
so you can make it whatever number you want.
Well, you can't in this case because we know that this number plus 2 plus positive 2 equals 5. Okay? Alex, that's a stretch. That number plus 2 equals 5. Okay? Keep your hands to yourself. Now, I'm gonna show you how to prove that n is 3. Here's how you do it. We have to eliminate the 2 on this side so that n is all by itself. When you're solving an equation, it means getting the variable n or y or x or z or whatever the variable is, getting that n by itself on one side of the equation. What does this line represent? Oops, I shouldn't have erased that. What does that line represent? It represents the two sides, the left side and the right side. Okay? So we need to get rid of the 2 so that just n is left on this side. Okay? Now, this is a positive 2, right? It's just plus 2. It's a positive 2. What is the opposite of positive 2? Negative 2. Yep. In other words, when you add a negative and a positive, what do they get? What happens? They cancel each other out and become 0. So if we add 2 negatives to the 2 positives, they cancel each other out. Okay? Now, there's a rule in algebra, which is what we're learning. There's a rule in algebra that says you can add anything you want to, any number you want to both sides. You can add a positive number or a negative number. As long as you add both, or add that number to both sides, the equation stays equal. Okay? So we could add negative 2, we could add negative 10, we could add negative 20, we could add any number we want to, as long as you add the same number to both sides. You can add any number you want to both sides. And that's a rule in algebra. Carson? It's true for any equation. You'll come out with the same answer, yes. Yep. So, why would we add negative 2? Why would we choose negative 2 to add to the left side? It's not the reciprocal, but the opposite of 2. That eliminates that 2. And that's our goal, is to get rid of the 2 so that the n is all by itself. Okay? So now n, this n, is all by itself. Now, what was the rule I said? If you add a number to one side, you have to add the same number to the other side. So what do we have to add to the right side? Not 2, we didn't add 2. We added negative 2. We added 2 negatives. These were 2 negatives over here. They crossed out the 2 positives. And we have to add 2 negatives to this side. What would they do? What effect would they have? Daria? And what would happen to 2 of these? They would be eliminated also. Now, what's left? What's left on this side? X? Positive 3. That proves that n is equal to 3. That's all that's left. Okay? So, by modeling this, I'm showing you what happens when you add negative to positive, or positive to negative. And we're going to use that process in order to get the n by itself, or to get the y by itself, or the x by itself, or whatever variable we have that we're trying to find. Okay? Let's go to our assignment, the worksheet. Start with number 1. Well, let's start with the top. Look at what we would do to solve this one. You have an x here, and then positive 9. The white squares represent positives, and the shaded squares represent the negatives, okay? So, what would we add to the left side in order to get rid of these 9 positives? How could we get rid of those? Carson? Negative 9. Yep. If we added negative 9, that would eliminate all of these. Wouldn't it? And then if we added negative 9 to this side, what would it eliminate? Yeah, all of them in this block. And what would be left? 2. That proves the answer. By adding negative 9, we proved that x equals 2. Okay? This is all we're doing, is adding a number to both sides in order to prove an answer. How about the next example? This one is x minus 3. We have to get rid of the negative 3's. You'd have to add what? Add positive 3. So we add 3 pluses, and then what? What does that do? It eliminates what? The 3 negatives. It eliminates the 3 negatives. And when we add 3 positives to this side, what does that do? What does that do? It gives you 3 more positives, which proves that x equals what?
2.
2. 1, 2, 3, 4, 5, 6, 7, 8, 9. It proves that x equals 9. Because 3 plus 6 is 9. Okay? You see that? By adding the 3 positives, we eliminate the 3 negatives on this side, and we add 3 more positives to this side, which proves x equals 9. Okay? Let's go down to your assignment. Alright? Here's how you need to show this. Use the pluses for positive ones and the minuses for minus ones. So how would you draw the model of x plus 6 equals 12? Draw a box for x, and then 6 positives, and then you can draw a line for the equal sign, and that divides it into 2 sides. Okay? We're going to divide this into 2 sides, just like on the notes. And then 12 positives on the other side, because x plus 6 equals 12. Then what? We have to get the x by itself. Alex.
Well, two things. One, I think you'd take, then you have to subtract negative,
Nope.
or just subtract
You'd add what?
negative 6,
Negative 6. And that eliminates the positives.
and then,
And
wouldn't this just be easier if you didn't draw it out? Yeah. Just kind of wondering, what do they have you do this for?
so that you could see how to solve an equation. Because when you're solving equations, you're really manipulating the numbers just like this. Except we're not going to use models all the time. We're starting with models so that you can see what's happening in the equation. Okay? You're learning how to solve. You're learning the process of proving it. It's kind of like this. It's when a lawyer goes into a courtroom, they have to prepare for how to prove something, right? They can't just go in and say, oh, my client's innocent. Okay, great. You're free.
Wow, that would be the greatest lawyer.
That would be, yeah, that's not how it works. The lawyer has to use the rules of the courtroom to prove his answer. And that's exactly what we're doing. You're the lawyer, and you're proving what the answer is by using this process, by learning this game called algebra. Okay? And there's rules in this game, and there's things that you can do just like any other game. Alright? When you're playing baseball, you can't just start running around the bases. Alright? Oh, it's easy to score a run. You just touch home plate.
Everyone just dives all the way.
Yeah, that's not how the game works.
Hit the ball, step on the
That's,
plate.
that's not how the game works. It's easy to shoot a puck into a net, isn't it? But it's a lot harder when you have to play by the rules and there's people trying to stop you. Okay? So, let's get back. This is a game. This is a game just like that. Number 2, you're starting with 8. And on the other side, you have an x and 2 negatives. What do you have to add? Have to get rid of the other stuff that's on the same side of the x.
Just do negative 8.
If we added negative 8, would that get the x by itself? So you've got to get this all by itself on the right side. You'd have to add 2 positives. Yep. To eliminate these. We have to get the x by itself. You're right. Now, we have to add 2 positives to this side. What does that prove? What does that prove? Jeremiah? What's left on the right side? The x. Yeah, the variable. So x is equal to what? All of this. X is equal to? Wait. How did we get this?
No, how do we get the
How do we get these two? Where did these two pluses or these two pluses?
Yeah, one side.
On the left side? Okay, so let's go back and I'll try to redraw this. We started with 2 negatives because it's a -2, Jeremiah. We have x and we have a -2 on this side, on the right side of the equation. You see that? So I drew an x, a box with x in it, and then I drew 2 negative signs which represent these 2 negatives. You understand that?
Yeah.
Now, I have to eliminate these 2 negatives in order to get the x by itself. How do you eliminate 2 negatives? What can you add? Add 2 positives. That's why I put these 2 pluses right here. I put those on the right side. And then whatever you put on the right side, you have to put on the left side. You have to put the same number on both sides whenever you're solving something. And that's a rule of algebra. If you add 2 positives to the right side, you have to add 2 positives to the left side. If you add 2 negatives, you have to add 2 negatives to both sides. Okay? And that's where these 2 positives came from. Does that make sense?
Yeah.
So we added these 2 positives so we could cross out the negatives, and then added the 2 positives on the left side. And how many total positives do we have then? 3, 6, 7, 8, 9. I crossed out one of them because I accidentally wrote one of them. So there's 10, right? And that proves that x equals 10. Okay? And this is the process you're going to do when you finish this assignment. Is go through and make sure you draw a line down the middle so that you have a left side and a right side. And then draw out each equation. Okay? And then at the bottom you can write what the x is. Okay? Wait, I did this one wrong. Okay? Any questions? All right.